Hello and welcome to section 8.4. We're going to be spending 2 days on this lesson here. It's a lot of material, a lot of properties we're going to learn about. First though is your answers for 8.3. Okay, so we're going to start talking about what different types of parallelograms we have. There are rhombuses, rectangles, and squares, and what makes them what they are, and the properties that they have. So rhombuses is a parallelogram with 4 sides. So it has all of the properties of a parallelogram, but it also has 4 sides. Similarly, a rectangle is a parallelogram, but it has 4 right angles, and then a square, of course, has both 4 congruent angles and 4 congruent sides. So these are kind of the definitions here. I mean, you just need to know what the different shapes are. So you don't have to write all these down. You just need to know that a rhombus is a parallelogram with 4 congruent sides, similar for the rectangle and the square. Now, because they're parallelograms, they have all these properties that the parallelograms already have. In addition, they have new properties themselves, more specific properties. So what we have is this world of parallelograms, and then we have rhombuses, we have rectangles, and squares overlap. So a square has all of the properties. A square has all the properties a parallelogram has. A square has all the properties that a rectangle has, and a square has all the properties that a rectangle has. So squares have a lot of properties. Let's talk about some of those properties. I'm just going to take a look at these 3 boxes here. So the rhombus, the first property that the rhombus has is that the diagonals are perpendicular. So you need to know that the diagonals of a rhombus are perpendicular. So now because a square is a rhombus, a square's diagonals are also perpendicular. And then for the rhombus, the other thing is interesting, the diagonals bisect the angles. So the diagonal is going to cut the angles of the rhombus in half. That's also very important. And if we have a rectangle, the diagonals are congruent. And because the rectangle is also parallelogram, the diagonals also bisect each other. So that's why you're going to see like all 4 of these parts here are the same. So basically AC and BD are the same. And then because it's a parallelogram, they bisect each other. So if I call this like A, we call that point like M, so like AM equals BM equals DM equals CM. All those parts are also the same. So lots of good stuff here. They're going to ask you a lot of these types of questions. For any rhombus, decide whether the statement is always, or sometimes true. Draw and sketch to explain it. So let's see, we have QRST, and they're saying when is Q and S going to be congruent? Well, that's always. And the reason is rhombuses or rhombi are parallelograms. And I know that parallelograms have congruent opposite sides. So that's the type of questions you're going to be answering. Okay, then let's take a look at Q and R. So when are Q and R going to be the same? That'll be sometimes, and only if both 90 degrees. So very rarely, but it could happen, and then it just basically becomes a square. Classify the special quadrilateral. So I know that it for sure has to be a rhombus because it has 4 sides. And it says it's a rhombus, that makes it a parallelogram. And that makes that 110 degrees. That makes that 70. And that makes this 110. So it can only be a rhombus. It can't be anything else. So you're going to be using reasoning skills like that. For any rectangle, let's see, EFGH. So EFGH is a rectangle. EFGH. Is it always sometimes true that FG and GH? So FG, this guy right here, and GH, this guy right here. Those 2 sides, are they congruent? That will also be sometimes. sometimes they could be congruent. They're generally not going to be, but it could happen. And then a quadrilateral has 4 congruent sides and 4 congruent angles. Sketch and classify it. So 4 congruent sides and 4 congruent angles. They all have to be 90 if they're going to be congruent, so that would be our square there. So properties of different quadrilaterals. We'll do this in class. That's a good question to talk about in class. And I'm not going to go over that. Here's your assignment. You're going to notice we're going to be doing a lot of problems. We're going to spend day 2 on this and doing more problems. We're going to prove some theorems in the next video. But I'm going to leave you guys with this for starters. Thank you.